My name is Lauren. My pronouns are she and her. Thank you so much for being here. My talk is called Why I Chose to Modularize the Ducks in My React app. So my journey to tech was rather unconventional and non-traditional, if you will. I didn't study computer science in college, but actually was an English teacher for 7 years before embarking on my journey of learning to code. During those years in the classroom, I spent a great deal of time lecturing about structure. And by that, I mean the 5-paragraph essay, the art of writing an outline, like really exciting stuff, rules of grammar, proper sentence construction. Essentially, all things structure, organization when it comes to a high school literature class. So this all combined with the fact that I'm also a Virgo means that I really like structure, and specifically like organized structure. At Ada Developers Academy, a tuition-free program that trains women and gender-diverse folk to learn to code in Seattle, Washington. Hey, what's up, 80s? Yeah! My peers were constantly giving me a hard time over my color-coded notes. But in my defense, this sort of stuff suits me. You know, it brings me peace and joy and sanity. And while learning to code, just like my old classroom, I loved when everything had its place. You know, with code, there's always a right and a wrong way. It either compiles or it doesn't. For example, it felt really satisfying when learning Rails, learning that the business logic must go in the model. Or with React, that the render function can only return a single function. As a newbie, I liked learning about the parts within code that have strict black and white expectations of implementation. You know, switching from humanities, where I got to talk about books and our feelings all day, to learning to code, you know, in just 1 year was overwhelming in itself. And so in search of something comfortable and familiar, I found myself gravitating towards and literally memorizing those rules. I loved the clarity, the concreteness, you know, the structure of it all. And discovered that it was at least one area during the wild and crazy world that is coding that I could actually excel and thrive in. And for those exact reasons, I, for a long time now, have idolized Sandy Metz and simply loved how strict her rules of practical object-oriented design are. I'm realizing I'm making myself sound like I'm really painting a picture. I swear I'm fun, I swear, like, I promise. Anyhow, when I joined my first software engineering team after Ada, it will come to no one's surprise to learn that I was like super overwhelmed by the massive code bases that so many companies have. You know, there are hundreds upon hundreds of connected systems for each org with different teams using different tools and different tech, and yet somehow they're all connected together, working with complex dependencies, and oftentimes, for the sake of speed of production, little structure. It felt like an unfriendly web of connectivity and interdependence that I didn't feel confident in making sense of. And my first week task, my manager sits me down and says, okay, just make sense of the 13 code bases that we use day to day. And of course, to rub salt in the wound, he's like, I vividly recall him saying like, it's easy, no big deal, it'll be fine. And like the interconnectivity of it all, it was a lot for me to take in, right? Like it felt like the wild, wild west of interdependencies, and my rule and structure-loving self needed to take some deep breaths. No, shocker, I like get overwhelmed easily, you know. But as he did, as like all of us do, right? And I'm sure we've all done before, I tackled the task, just as I'm sure what's that phrase like, how do you eat an elephant? One bite at a time, which I like don't get that phrase, really. But like, you know, okay, right? So okay. All that to say is I slowly did one file at a time. And soon I learned that our team was doing some pretty cool stuff. We were responsible for aggregating and pulling user data and code from over 20 different orgs and databases to create a comprehensible, analyzed, summarized, most sold list each week. So the data it was aggregated, but it wasn't done perfectly. And so each week, a PM on our team had to curate and edit that top 20 titles list before publication using a web app our team had thrown together using a pretty outdated and logicless templating system called mustache.js. Yeah, familiar? I see nods. And then in combination with handlebars. And because this list curation process was so incredibly cumbersome, during my first weeks on the job, our team was tasked with optimizing that app. So the decision was made for many reasons, but the biggest one being that the code was, a complete hot mess of spaghetti. So now handlebars and Mustache are not necessarily bad tools, right? As I said, though, Mustache is a logicless template library. It's perfect for binding simple data or an HTML template. But that's really it. It's just too simplistic for what we needed. And while simple can be good, it's generally not used to describe robust web applications. So what started out as a teeny tiny app morphed into, as I mentioned, a spaghetti code of a mess in just a few months. My team referred to it as kludge, meaning that it was a quick and dirty solution that was clumsy and inelegant and inefficient, difficult to extend, and hard to maintain. Do you want me to show you it, just for the sake of awe? Oh, excuse me? With my technical difficulties, this was an interesting choice to just show you for the sake of showing you. But this is the HTML file, index.html file, and it is massive. It is long. You can see over here in the viewfinder, it goes for a while. And it's never has a long file, massive file like this done well for us, right? In the world of maintainability and scalability. It was difficult to make modifications. Look at this. It goes. And anytime, the JavaScript files are defined in here in one place, and it makes it like reading a book, essentially, but not knowing where the chapters are or not knowing where you are in what place. So anyway, that's what that looked like. And we were pissed. We were ready to do something different with it. It was difficult to maintain, or difficult to do much with. Oh, there it is. Okay. Sorry. All right. So as you can imagine, when I first dove into that code base, my type A desiring structure self was itching on the inside over it all. But I was lucky. My manager agreed, and so instead of a refactor, he suggested a complete overhaul. And we got to start fresh from scratch. We decided to invest in the art of doing it right for the first time. So this encouraged us to dive into the interwebs for research. We considered the frameworks out there and decided to let our needs guide us. We knew that we required a front-end framework that allowed us to easily and conditionally show DOM elements based on criteria, build an interactive client experience with many views and many different levels of user access, and to easily consume multiple APIs. So we came up with this list as they were the requirements that had caused us a great deal of difficulty, and achieving them had felt really burdensome and complicated with Mustache. But after doing some research, we discovered that we were in fact describing all things that would be quite a breeze with the JavaScript library. Any ideas? React, okay. So I had previously built an app using React Native, and it wasn't just because it was the hot tech at the time, although it certainly was. But our research told us that it would supply us with some pretty cool capabilities, and the aspects that we were most excited about were, the ability to render on the virtual DOM, reusability of the organized components, the fast learning curve, native compatibility, lastly, just innovative developer tools. Essentially, we were pumped about its promise of speed and ease and capabilities, and it felt as though all signs were pointing us towards React. But maybe you're not as easily convinced as we were. Let's pause a moment and cover why React is so awesome. So by definition, React is a JavaScript library developed by Facebook in 2011 for building user interfaces. It's the view layer of web applications, as in the view in the MVC, the model view controller. But this definition, it doesn't really do it for me, right? It's one of those sentences that I have to read over and over in my head multiple times before I can even come close to making sense of it. So instead, let's break it down into comprehensible pieces, or components, if you will. And yeah, my first coding joke. Okay, so that's what React is really all about. components. Components are essentially a piece of user interface. So when you're building an application with React, you build a bunch of independent, isolated, and reusable components. You then compose them all together to build complex user interfaces. So every React application has at least one component, which we'll refer to as the root component. One component represents the entire application and contains other child components. So every React application is essentially a tree of components. Here's an example. Let's imagine we want to build an application, say Twitter. We can split that page into components like the nav bar, profile, trends, feeds, and those are all the different components. And to represent that in a tree, we have app at the top, and below we have the nav bar, profile, trends, feed, and then the feed components can include several tweet components. And each tweet can include like component, which we can then reuse on other pages or even in different applications. So as you can see, each component is a piece of the user interface. We can build the components in isolation and then put them all together to build complex UIs. In terms of implementation, a component is typically implemented as a JavaScript class that has some state and a render method. The state here is the data we want to display when the component is rendered. And the render method is responsible for describing what the UI should look like. And the output of the render method is just a React element, which is a simple plain JavaScript object that maps to the DOM element. But it's not a real element. It's just a plain JavaScript object that represents the DOM element in memory. So React keeps a lightweight representation of the DOM in memory, which we'll refer to as the virtual DOM. And unlike the browser or the real DOM, this virtual DOM is cheap to create. And so when we change the state of a component, we get a new React element. So React will then compare this element and its children with the previous one and figure out what's changed, and then it'll update a part of the real DOM to keep it in sync, with the virtual DOM. So that means that when building with React, unlike vanilla JavaScript or jQuery, we no longer have to work with DOM APIs in the browser. In other words, we no longer have to write code that queries or manipulates the DOM or attaches event handlers to the DOM elements, which is awesome. So we simply change the state of our components, and the React will automatically update the DOM to match the state. And that's exactly why this library is called React. Because when the state changes, React essentially reacts to state changes and updates the DOM. Okay, so this all sounded like dreamy to us, felt really awesome, and again, we were stoked to give it a try. But I should be super clear, because I've just spent a good amount of time talking about all the good things that are React. There are, however, a few drawbacks, and I'd be remiss if I didn't cover those. So my team realized pretty quickly that our architecture tree would probably end up becoming a bit more complex than the example I just showed us, and that we'd be passing state as props around the app quite a bit. Now, React advocates for a single directional flow, and things can get messy when we want to keep our data in sync, when two or more components share that same data. Ideally, the source of truth of that data is only in one place. The React docs encourage you to lift state up if you have two children that need to access the same data. This means putting the data in the nearest ancestor of the two components. But if the two components are very far away from the tree, the nearest ancestor component could be at the top level of the component tree. No. To complicate things even more, the intermediate component may have absolutely no usage for the props that's being passed. It just happens to be stuck in the middle and has to pass it along. No thank you. My favorite analogy for this is the idea of me wanting to tell my cousin a story, but instead of being able to tell her directly that story, I also need to tell my aunt. Now that's fine if it's a little non-embarrassing story, but say it's something I don't necessarily want my aunt to know about. Bummer, dude. Like, I still have to pass it through her, regardless. So the top ancestor has to pass the data through several intermediate components along the way to get to the proper component. And just like the game Telephone, some of us may have played as kids, this creates a million different opportunities for developer error or unclarity for future users. The original story can get muddled, and someone could easily get confused as they try to trace the props as they get passed down between many components. AKA no bueno. So to view it another way, once state is being passed back and forth and up and down between the component trees, it's easy to manage that things can get complicated real quick. And to add insult to injury, my girl Sandy Metz taught me to always fear coupling. And that's happening like big time between each component and its parent. So to try and move a component around becomes super complicated because there's coupling going on between the component and its parent and then between the component's children that it's passing props to. And to no one's surprise, this impacts performance because every update to the data made will cause all the children to re-render, which can cause massive performance and speed issues. Okay, that's where we were at. We know the good, we know the bad of React, and ultimately we felt that the good definitely outweighed those drawbacks, but we knew that we'd need to find a solution for managing our application state if we were going to build such complex applications. We wanted our application to scale. You know, obviously we wanted it to be maintainable for many months or years, right, into the future. And we knew that we wanted to maintain our sanity when it came to state management. So that's when we discovered Redux. It's the state container superhero that saved our day. Yeah, okay. Okay, but like, let's chat about that, right? So Redux, what is Redux? How is it different? Or how does it change React, if you will? Or what problems does it solve? And ultimately, like, why would one say yes to the dress that is Redux? You know, okay, so by definition, Redux is a state management tool for JavaScript applications. And while it's frequently used with React, it's framework agnostic, meaning that, like, it's compatible with many React-like frameworks, such as Angular and Ember, Vue, even just plain JavaScript. So learn it once, and you can use it with a whole lot of things, like a sales pitch person. Okay, I don't work for React or Redux, but you know, okay. But I'll acknowledge it, right? Like, again, our definition here, it isn't working for me. You know, it doesn't tell me why or how it solves React's problems that I just described. Let's go back. Remember the chaos that was the mess of passing data around the components. That is what Redux successfully helps us make sense of. So with Redux, I can pass data, or that embarrassing story about my most recent Bumble dating escapade, to my cousin, without also having to tell my aunt about it as well. AKA, I get to avoid the chaos of the story being bounced between all of the components or like all my crazy uncles, and I just get to update that one or change it, right? This all becomes possible because of Redux's most important principle, which is the universal store. So let's talk about what that is. As I said, it's a state management tool. The big thing to remember is that the entire state of the application is stored in one central location called the store. I'm realizing that really might look like a nipple. All right, my bad. My bad. Okay, moving on. Meaning that each component of your React app gets to have direct access to the state of the application without having to send props down to child components or using callback functions to send back data to a parent. And that's pretty dreamy. Redux provides a central store that can hold data from anywhere in the application. Another analogy can be painted that with just React on its own, say you went to the market and only wanted to buy an ice cream cone, but instead you'd have to buy, you know, everything, not only in the dessert aisle, but the produce and deli as well. In React, you don't get to be selective of the data and how much is passed on. But in Redux, you're allowed to, it allows for those individual components to be connected to the store. And it's encouraging you to extract just the pieces of the data that each component actually needs, as opposed to all the data that exists. So data no longer is being passed down through multiple levels of components. You know, now code is simpler. It's fewer components are involved. And rendering performance is optimized. These are all good things. Plus, because Redux also follows the one-way directional flow, all of the logic in the app becomes more predictable, easy to understand for your fellow teammates in the future. So because data is normalized, you won't end up with multiple independent copies of the same data that are unaware of one another all over the place. To put it differently, Redux completely eliminates the messy tunneling that can happen when you're passing data from a parent down to many different subcomponents and manipulating it all in those places. Okay, so we sold by my explanation? At this point, my team was, and Redux sounded pretty magical, dreamy to us. So let's break down the basic steps of implementing Redux. Before I do, I want to introduce these principles as I'm going to refer back to them pretty often. So the first is that everything that changes in the app is contained in a single object called the state or the state tree. This makes it easy to create universal apps, as the state from your server can be serialized and hydrated into the client with no extra coding effort. Next, it's important to know, that the state of the app is only changed by pure functions, which only return the exact same output for the given input. To specify how the state tree will be transformed, you'll compose pure functions, called reducers, that take the previous state and action and return the next state instead of mutating the previous state. Okay, and lastly, the only way to change that state is to emit actions, which are objects describing what has happened. So this ensures that neither the view nor the network callbacks will ever write directly to the state. Instead, they express an intent to transform the state. Now, this is a diagram of how all that happens. I'd really love to lift the veil on what truly is going on here and make sure that each step along the way makes sense. And I'll do that by utilizing a pretty straightforward example application. That example is a React app that aggregates data and showcases a list of the most binged TV shows of 2018. I am a millennial, after all. So you can imagine that each color here is a different React component. Let me show you what that code actually looks like. Okay. This was the old one. Goodbye index.html file. Like, that one's gone. Okay. Cool. So this is the root app, or root component, and it calls the other components. It calls first the new title component, and that's the ability to add something new, and then a list view. The list view then calls the individual component, which then has further metadata. And it's broken up, stored all within the components. Really simple, I'd say. It's running right here locally. And again, like I didn't even add any CSS into it. I just wanted it to show it for our example purposes, which will be to transfer it into a Redux state organization system. So, Okay, yes. Currently, with just React, the data in this app flows directionally downward like that. But as I just said, I want to add Redux so that the state and the data transfer is going to look more like this. So referring back to the Redux flow diagram, the first thing that we have to build is the store. So it's so crucial to remember that in the store in Redux, it's just like our human brain, right? It's absolutely fundamental. The state of the whole application lives inside the store. So to start playing with Redux, we should create a store for wrapping up the state. Shall we do that all together? Yeah? Yeah, let's do it. Let's build Redux. Okay, because it's not going slow toggling between those two at all. Okay, so here we are. Actually, before we do that, we should turn off our server. And in fact, I'll just start from the beginning. You'll run Npm Install Redox. And so while that's happening, let's go back to our folder. And in the source folder, we're going to create a folder called, we'll start with just Redux, right? And in Redux, I said that we're going to start with a store. We'll create a folder called store. In there, we'll create a file called index.js. Okay, in there, we will handle a couple imports. for things that we actually, a relative one that we haven't built yet, but then we will write a function called create store, and it's going to call root reducer. Okay, and then lastly, we're going to export default. Okay, awesome. So that's what we'll start with. Create store is the function for creating the Redux store, which you may also pass in an initial state to create store. Can I make this bigger for you all? Sorry about that. Might be. Most of the times you don't have to do that, though. Although passing an initial state can be useful for server-side rendering, traditionally the state comes from reducers, which is what I'll do here, and it takes a reducer for the first argument, root reducer here in our case. But wait, okay, I'm sorry, let me back up, because I haven't really explained what reducers do yet. So, okay, and let's go through actually then what reducers are and how crucial of a role that they play in the world of Redux. So what are reducers? What do they do? Let's go back to our diagram. In Redux, reducers provide the state. The state is not something that you necessarily create by hand. Reducers specify how the application state changes. Remember, one of the principles of Redux is that the state is immutable and cannot change in place. In plain React, the local state changes in place with the function setState. But in Redux, you cannot do that. A reducer is just a JavaScript function, and it takes two parameters, the current state and an action, which is why the reducer must be pure. And again, pure functions are those that return the exact same output for the given input. And creating a reducer is actually pretty simple, so let's do that all together. So in our Redux folder, right now we'll add another folder called reducers. Yes, that was a pretty quick transition. And here, we want it to, reducers. Okay, and in there, we'll add a new file called index.js. And in there, we'll call initial state. And we're going to pass in an empty array. Go there, and then we'll go export default, just as we should, root reducer. Sick. Okay. Oh, thank you. Thank you so much. Okay, anyway, so this reducer is sort of a silly one. It returns the initial state without doing anything else. But definitely notice how the initial state is passed as a default parameter. So now let's go back here, and the reducer are without a doubt like the most important concept in Redux. Let me say it again. Reducers produce essentially the state of the application. But this then begs the question, how does a reducer know when to produce the next state? Okay, hopefully it looks like that. Well, that's where actions come in. One of the principles of Redux is that the only way you can change the state is by sending a signal to the store. This signal is an action. Dispatching an action is the process of sending out a signal. And how do you change an immutable state? Remember, you don't. So the resulting state is a copy of the current state plus the new data. And you may be thinking, whoa, Lauren, that's a lot of data to know. But the reassuring thing is that Redux actions are nothing more than JavaScript objects. So this is an example of what it might look like. So we know the drill. Let's create a simple action together. We'll create an actions folder, an index.js. Okay. In there, a new file. And in that, we'll add here. Okay, so every action requires a type property for describing how the state should change. And it's really just a string. That's this piece right here. And the reducer will use that string to determine how to calculate the next state. And you can specify a payload, as I did, if you'd like. In my example, the payload is the new show. So It's best practice, though, to wrap everything up, those actions, into action creators. And the reason we would do that, yes, there it is. Okay, and hopefully it looks something like that, which it did. Okay, and so since types are just strings, and strings are prone to typos and duplicates, it's better to have the action types declared as constants. So as I said, it's best practice to wrap every action within a function, which definitely helps to avoid errors that would be difficult to debug. So let's also do that quickly and create a simple action creator. Again, I'm going to create a new folder. Constants. Oh no. For those of you that were not paying attention, I just constants. Oh, look, I can change it. Oh, will that work? Okay, and here, action types. Okay, .js. Oh, I could have called that index as well. Anyhow, we will export this, and then all we have to do is go back over to our actions folder, and what we need to change here is delete the quote marks here to actually pull it in, but of course we need to import it as well. So import, what's happening? Oh, I'm so sorry. I have no idea how to fix that right now, but I'll figure it out for you all. It's so slow-mo. Okay. All right. Can you see now? All right. Sorry about that. My bad. So here you are. I just created the actions, or I created a constants file, and I have to delete this one. And in here, I added add show. And here, I just deleted the quote marks around these, and I'm going to then locally pull or do a relative file of an import. And so that's going to look like add show from constants, and I think I called it action types. Cool. So, are you all still with me? No? Okay. Or maybe yes, okay. So, maybe it'd be helpful for us before we go further just to recap really quickly the main concepts and kind of things that we learned. And of course, I'll wait for a visual so that you can see that, because that's helpful. This is the slide I usually show when I ask you if you're here, like, slow down. Okay, so the Redux Tour is in charge of orchestrating all the moving parts. All the state lives in a single immutable object, and as soon as the store receives an object or an action, it triggers a reducer, and the reducer returns the state. The order sort of kind of looks like this. An action first occurs within a component, such as someone trying to add a show or a filter view, see the details, even like deleting a component. Then that calls the action and action types, which then grab the particular reducer that will update or modify the state, and once the state is changed, the view is re-rendered. And ta-da, there you have it. Okay. So our code, though, we created one reducer, and an important refactor that should happen to set up, we need to kind of make some changes there, because the reducer calculates the next state depending on the action type, and it should return at least the initial state in the case that no action type matches anything. So we'll do a really fast refactor and change our reducer to become a switch statement. So doing that, can you all see that? Okay. So here in our reducer file, we will change this to look something like that. How does that look? Yeah? Cool. Actually, I set us up because it is valid code, but the above reducer breaks the main Redux principle, immutability. So if you look here in this line, array.prototype.push is an impure function. It alters the original array. Making our reducer compliant, though, is super easy. We can use concat because that, in place of push, and that's enough to keep the initial array immutable. So what we'll do is we will change this here to become, let's see, state, yeah. And then we'll pass shows state.concat as opposed to push action.payload. Cool. we could make it even better if we wanted to add in a spread operator, which would look really good too. But let's head back to our PowerPoint. So notice, though, that when we were doing that the initial shows array doesn't change in place. Remember, that's super important. The initial state object doesn't change as well. The resulting state is a copy of that initial state. And then our Redux code looks like pretty bomb, hopefully. Well, let's just double check that it looked like that. Yeah, okay, cool. I'm convinced. So hopefully it's not overkill to be like, all right, we're familiar with Redux now-ish, right? We know the vocab terms. We know its implementation. Let's revisit really quickly, though, the reasons one might choose to add Redux on top of the React to help manage their application state. So centralization, or centralizing the state, makes it super easy to implement things like logging changes to the data or persisting data between page refreshes. And predictable state updates makes it easy to understand how the data flow of an application works. And lastly, using those pure reducer functions makes logic easy to test, and it enables useful features like time travel debugging. Essentially, Redux is helpful in those complicated yet common scenarios when you have multiple components that are not closely related to one another but want to share all or the same data. Okay, so like all of you here, we had learned the basics, and my teammates and I were excited to begin creating an app with React and Redux, and we're ready to be off to the races without a care in the world. Except, you may have noticed that while we were setting up our Redux, and I had to keep going back and forth, and it was like pretty painful in the addition of all those additional folders and files, etc. You know, imagine adding all of the functionality of a traditional app, right? If you're going to continue down this path, it's pretty easy to imagine how things could get crazy messy and confusing really quickly. So you'd have to edit, right? The constant starting in one file, and then edit the reducer in another. Okay, go there, and then you'd have to edit the actions in another, and then call the action creators in yet another file. You know, this means that even adding a really small piece of functionality requires you to edit and manipulate and toggle between a ton of different files. So, and what this structure, if you will, is called by type. And it's super common. Yeah, get out of here. Okay, it's organized by type. As we just saw, you end up hopping back and forth between files for a single piece of related functionality because the constants, actions, and action creators are imported into the reducer file, and the action creators are also imported into the container to then be dispatched. And all of that kind of becomes a little annoying. Wouldn't you agree? Yeah. Okay, here's what I found to be really wild, okay? There is actually no prescribed one way of organizing your Redux files. This by type method is super common and is taught in a ton of tutorials, but obviously it's sort of flawed, right? My theory is that oftentimes when you're learning about Redux and the roles of actions and reducers, you start off with really simple examples, and most tutorials available don't take you to the next level. So if you're building, though, something with Redux that's more complicated than a to-do list, you realize pretty quickly that you may need a smarter way to scale your code base. These actions and constants and reducers are all related, but in a fractured state, and honestly, switching from one file to the next only takes a few seconds. Yes, I get that. But it makes my head kind of fuzzy, and it's really slows down my personal production efficiency. And honestly, simply put, it's hard to maintain. So, thus, yet again, all of my English teacher organizational habits came rushing back to me, and I knew that there needed to be a strategic and thoughtful way to organize my code structure and architecture. And I dove into the research and Medium files and articles, knowing that there had to be something out there that would offer me some peace of mind. And I was right. There are a lot of ideas out there about it. Some people were suggesting online that a solution to this frustration might be to organize your code by feature, as in encapsulating a component, the container, its state, the store, and its behavior, the actions, into a single folder, all following React's component concepts. But this means that you'd have to tie a slice of the Redux store into a container, and that is completely counterintuitive to the core of what Redux promotes. So I was not about to adopt that pattern. And so, back to the drawing board I went, and further research led me to ultimately discovering, ta-da, the moment you've all been waiting for. Based on the title of this talk, Ducks to the Rescue. So, what are ducks, though? Really quickly, Erik Rasmussen coined the terms when he observed, well, okay, Java has jars and beans, Ruby has gems. I suggest we call Redux bundlers ducks, as in the last syllable of Redux. Ho-ho! So he realized that he was building out as he was building out Redux apps, that he was doing it in one piece of functionality at a time. He kept needing to add action type, actions, reducer, tuples for each use case. He was keeping these in separate files and separate folders as I did. However, 95% of the time, it was only one reducer action pair that ever needs its associated actions. Thus, it makes more sense for these pieces to be bundled together in an isolated module that is self-contained and can even be packaged easily into a library. So Ducks is essentially a proposal for bundling reducers, action types, and actions all into the same file. But why specifically would the organization structure be this? Why would that be a solution to our problem? Or rather, why get excited about ducks like beyond their adorableness factor, that is, right? So Ducks seeks to solve the issue of that toggling back and forth repetitive nature by organizing that you get when you organize by type. So with Ducks, rather than splitting up all related code, we can package it into Redux modules. Okay, that's enough talking. I want to show you how easy it is to create that Redux file, do your refactor all into one. So, okay, we just need to, you can see my screen, yes? Yes, you can. And one last folder, one last file. Let's call our Ducks. Sometimes I call it modules, but like, let's get a little crazy. Let's live a little. Let's call it what it is. It's a duck. So here we are. The first thing that we're going to do is grab from our action types from our constants file. So over here, I'm going to grab that, and I'm going to go back to my folder, and I'm going to write an export statement. Check for my typos here, because I'm going to try and go fast. Add show is going to be set to, boom. Oop. Okay, sick. Now, the deleting, and this is the really fun part, gets to begin. We are going to go ahead and just delete that first folder that we created. Goodbye, constants. See you never. Okay, now we'll do the actions. And in this folder, we will grab all of that. Back in our index, we will write another export statement, pop that in there, and then see a action folder, never again. Yep, I said that twice. Okay, now, reducers. Like, let's just grab it all, you know? Let's go crazy. Grab that piece from there, and then plop that all. Oh, you know what? Don't get too excited. We have to add an export file. All right, bam. It's Redux. Or wait, our Redux is Duxed. That's it. Oh wait, no, I'm not done because I didn't reduce. All right, check it out. Like, suck it, Redux. Like, that is all now just in one file. Maybe that's not as exciting for you, but I love the ease of that. I mean, right, like it's little, it's small, but it's this idea that, that like it feels like it's modularized, it's creating this, that's really what the Ducks looks like. So hopefully our code looked a little like that. Yeah, I think it did almost on it. Yes, live coding for the win. We did it, we made our Ducks. So I find this to be pretty incredible because duxing is a way of structuring an app to become more modular. Like, yes, that's a really sexy buzzword in the world of software engineering, right? But like, honestly, this is great because it becomes obvious what piece of Redux is handling what functionality. And on a completely practical level, you no longer have to scroll through masses of files before finding, the one you need to work on. And in theory, it would be pretty straightforward to switch out Redux for any other state management library if the need ever arose, because those files are completely separate from the React portion of the app. But this is only one way of structuring your Redux. There's plenty of others out there. And the simple fact that I'm standing up here encouraging you all to explore ways to creatively define what might work for you and your team means that maybe that structure-obsessed self or that type A person that was like, maybe she's leveling up and becoming that software engineer that seeks to define her own rules and doing whatever is best for your code and your team. Ultimately, maybe that's the right choice. What I love about Dux is how clean and clear it is. It removes a lot of unnecessary boilerplate, and you can easily then add an action or a field to the reducer by changing it in a single file. Thus we were convinced, and maybe you all are too. To really bring things home, I thought it'd be interesting to show you my team's more developed Redux file that has a ton of other functionality in it. It has the ability to add to the database, which is what we all walked through, but this one now also has reducers to retrieve all of the data from the API, edit the data, and then see the associated titles, and filter it all in one view. And then here we have really a snazzy switch statement. So my team, ultimately, we really liked the ease of that. And I think this is ultimately really just the beginning of where things can go, right? This is one way of structuring things. There's so much in the world of React and Redux to explore. And that can be things like Webpack or React Router. I have those on a slide really fast. Or Thunks or Sagas for the middleware. It's just, I've had an incredible learning experience for me. Hopefully, you got something out of me sharing this all with you today as well. I really hope that some of you are walking away from this talk feeling as though maybe React, maybe Redux aren't so confusing or scary anymore, and that maybe you were convinced by the Dux model of organization. I think it's so fun in this world of React Redux, all the different things that we can be doing. There's hot reloading, really just a whole host of other technologies out there for you to explore. So, go forth, have fun, play, and maybe try out the Dux modularization. I don't know. Thanks so much for listening, though. My name is Lauren, and I'd love to chat further. If you have any other wacky questions, let me know. I'll be around. Here's some resources for you if you're interested. Have a great day. This is the Rasmussen original GitHub repo. So if you're interested in learning about Dux specifically, check that out. Thanks, guys.